Hello everyone, today I am going to show you how I built this racing game, or we may change to a flying game. Let's quickly look at these codes I made, and around 300 lines of them, and let's run it. Here we go. Let's add more objects, add my own car, and create more obstacles or vehicles on the road. Let's make some collision shapes. When the player is hitting the cars, it will bounce off in opposite direction and push aside and make it stop. All these I am going to show you the algorithm and make it like a game. As you can see, I created a green rectangle for collision detection. When you are out of the boundary of the road, you will see a significant drop in speed, and you cannot accelerate to a much faster speed. You will see the road can be curved or bouncing up and down. I will show you how to make these roads look like a curve, and in fact these are the fake curves. And we will use sinusoidal function to create the up and down of the road, just like the real roads. As you proceed further, more cars will be created on the screen. When you reach the end of the loop, you will automatically go back to the starting point so that the loop could go on forever. First of all, we need to build a class, let's call it line. Note that we have self. Small x, small y, and small z, they represent the actual 3D space dimensions. To implement the roads display on 3D space, we make a function called drawQuad. Here is the code for drawing these trapezoid. You need to input x1, y1, w1, x2, y2, w2, 6 parameters to draw the trapezoid. Now let's run the function and see what happens. Here you go. As you see, the road was displayed like in 3D space. In fact, it's only 2D space. We used this 2D to fake the view which looks like 3D. This skill is called Pseudo 3D. From the 3D projected to the 2D screen dimension, we are using a function called projection to do this. Here shows the formula for doing this projection. For details, you could look into the website with the following formulas. Here shows the representation of variables that I am using for this projection. As you see, self.scale equals d divided by z camera. I used self, small x, small y, and small z to be the x world dimension in the above formula. Self, capital X equals x screen, while self.capital Y equals Y screen, and W to be screen width divided by 2. After all the consolidation, we come up with the following 3 formulas which are used for the projection. Okay, next you can see I build a line to be the instance of line class. Line.z represents the depth coordinate of the image. Line.z equals I times segment length plus an extremely small floating number. The addition of this is to avoid division by 0 that causes the error. Here shows how I build the road. You will x and x plus equals dx, which are used for generating curved roads that I will show you later. At this moment, we don't need to consider that value yet. Finally, we have drawQuad function I showed earlier that is to draw gray color road, black and white road boundary, and grass which is outside the road. Here we show the road. This is the straight road, and from the projection, you will notice it looks like a real 3D road in front of you. Great, so this is the basic display of the racing car game. We are going to using these for moving your car and place more obstacles later. Next, I am going to start the input method where I can move the car forward. Let's do it. Let's define a new function called input method. First, define the keys equal to pygame.key.getPressed. If a certain key is pressed, then we will do something here. If keys pygame_up, then we are going to create a speed. Let's call self.speed equal to segment length, which is, for example, 200. Actually, we define the road consists of pieces of segment joining together. The segment length is one of the piece as shown like in the diagram. For details, you could visit this website which has detailed explanation on how this mechanism works. Next, if the down key is pressed, then we would have self.speed to be negative value of segment length. So this is the reverse direction. Later, if nothing else, then self.speed equal to 0. Now let's work with the left and right direction. If left key is pressed, then we set self.player x to be negative equal to 50. If right key is pressed, we set self.player x to be plus equal to 50. These left and right will control your car to turn left or turn right, which I'm going to show soon. Finally, we need to update the position of our car. This will be the accumulation of self.speed over time. So self.position plus equal to the self.speed. Right? Let's put the self.input function to the main loop. And here we have to add a while statement to make sure the position will not going out of boundary. N represents the matrix size of line segment, that is, the maximum number of segments. If this is larger than that, the self.position has to be adjusted and reset back to 0. Likewise, if our position is negative, then we have to reset back to the positive. Here we pass the n to the input function. Likewise, if our position is negative, then we have to reset back to 0 by adding total number of segments. After that, self.start position is the current position, which is to be divided by segment length to get the current positional status of where we are in the whole road segment n. Note the segment start from 0 to n. Now let's run the game and see if it works. Here we go. When I press the forward key, the car looks like moving. I just found there is a mistake. I should have used else if instead of if. Otherwise, the else statement will always refer to the last if statement and cause some strange behavior. Let's correct this. So we are moving forward. Awesome. Looks quite nice. When we press the left key, it moves left, and right key, it moves right, and you are free to move. Right now, we have a working racing track, and we can move our car forward and sidewards. Great. Let's move to next session. Let's design the racing track. I have defined the segment length to be 2500, for example, and each segment length is 200. So by defining the segment number, we could design the road track whether it's curve or up or down. Let's the starting point is 0 and end is 2500. Now I would like to design this portion to have some curve from 300 to 700. Let's say if I greater than 300 and smaller than 700. So line.curve equals 0.5. Positive means right curve. So next. If this is left curve, this value will be less than 0. Let's say larger than 1000 and less than 1300. Line.curve equal to minus 0.7. Let's run the track and see how this impact the road. So here we go, we have the right curve in front of you when we are between 300 to 700 segments. When we are between 1000 and 1300, it turns to the left curve. Next, we would like to move the road up and down like sine curve. Let's say when value I is greater than 500. Line.y equal to sine curve. The argument is being value of I divided by 30.0 and finally times 1500. Actually try with your numbers to see which one fits your application. Now running the track you will see some difference. When you are close to the 500 segments you will see downwards. Up and down, right? It's running perfectly as expected. Awesome. When you reach the end of 2500 segments, it will just return back 0 and you will start from the beginning so that it will repeat itself and go forever. You will see there is very strange line at the bottom of the screen. To remove this, let's change the value for the screen height to 1000. Now this strange line was successfully hide up and you won't be able to see anymore. It's time to load the building's images to the memory for displaying use. Let's add a number of buildings. For I in range from 1 to object number, self.sprites.append. pygame.image.load with f string. Under the folder image / i.png, and then convert alpha to make it transparent. Alright, images are all ready now. Let's define where the buildings appear on the screen, that is, where to locate them within the segment 0 to 2500. For index in range, let's say from 1 to 10. Ops, there should be 13 images, so let's change 10 to 13. If value of I, modulus under a random choice, this random choice refers to the distance between buildings. Modulus operator always returns the remainder of division. Since there is no choice function, let's import choice from random module. As you see, I have designed the self.distance z, which is a collection of z distance. The choice will be from one of the number of this list. I also define another attribute which is a collection of distance x to track, which refers to how close is the buildings to the side of the road track. The larger number means more far away from the track. Back to here, if this remainder of division is 0, then we are saying line.sprite x equal to the choice of the list called self.distance x to track. From the random choice, we say the select object is the random integer between 0 and object number -2 so that we could generate random buildings at random locations. We don't have random integer function so that we need to import it from random. Next, line.sprite is equal to self.sprites. From there we select one of the object from the list. Look, it does not seem to have any buildings. That's because we hadn't used the blit function from Pygame yet. So, here for n in range, Remember the self.start position, which is the start segment. So from self.start position plus show segment number, which refers to the number of segment to be displayed on the screen. An endpoint is self.start position with a step of -1. From the settings.py, we define show number of segment to be 300. So, for each of these, we say lines n modulus n, which is the line class, so we can access to the drawSprite method. Here is the drawSprite method in details. The first argument being the self.screen. Let's run it. Here we go, you see lots of buildings at both sides with top buildings and trees. Let's move the car and see what happened. As you proceed further, you will see more buildings ahead of you. Well, awesome. Let's go to the next part. Now let's try to do one very interesting thing. Let's fly the car. Before doing this, let's define the flying keys. As usual, if keys when pygame.k_w key is pressed and self.player_y is not more than elevation limit, this value you can find in settings.py. Let's define it 30,000. This is to limit the height of car it can fly. Well, if this condition is met, let's say self.player_y plus equal to, let's say 50. Likewise, we set s key following the same pattern, except it is -100, so this mode is for landing the car. Since our car cannot below ground, so we need to give a condition, let's say self.player_y to be larger or equal to start elevation. Finally, as you may imagine, self.player_y minus equal to 100. We should be good to go. Let's run it and see what happens. When you start to press the key W, you are going to see you are taking off. And you are flying the car. Great. Awesome. Let's enjoy the flight. Now it's time to land the car. If you want to see my next chapter for placing enemy cars and doing collision check, please subscribe and give a like. That's the end of this video section for the introduction of Pseudo 3D. Thanks for watching. Bye bye.